All right. So, as I mentioned, one of the main reasons for taking time on this is it ties back to what you did in the first half of the course where you created stored procedures in this style. And we're going to go over the fact that we can actually create new stored procedures whenever we need to or modify them as required, right? Just right in Visual Studio itself. Okay. So, dynamic filter, what we're referring to there is in the old days, sometimes we would actually have a group of different stored procedures set up to filter this way, that way, and so on. So if you wanted to filter by a range of order dates on customer orders, right, you have one stored procedure set up for that. And a different stored procedure for filtering or sorting on something else, right? And then you swap which stored procedure you were going to call depending on what it is you needed to filter by. But this approach is more flexible in that we can just have one stored procedure set up. Oh, okay. We gotta watch out for those trolls out there and get our virus protection on, I guess. Anyway, so we can have one stored procedure set up to handle multiple filters. So that's why we're kind of calling it dynamic, because we might filter by one or more criteria all at the same time, right? Basically, the most common three situations are, as we mentioned before, foreign keys. Whenever you have a foreign key, it's like a lookup value. It's usually the first thing you end up filtering by, like orders by customer, right? See all the order history for one customer at a time, that type of thing, right? A text string, right? Searching inside of description fields, comment fields, name fields, what have you, right? Now there's two kind of variations on that. Obviously, sometimes you want starts with searches, right, or filters, where you're looking, it starts with these characters, but it could have anything after it. The other one is contains, okay, and of course then there's an exact match, but that's less common than the other two by far. And then ranges of values. Now those values could be dates. Okay, that's a very common thing in business in particular. You're always tracking things by quarters and weekly sales, et cetera, right? But it could be ranges of numbers, ranges of even alphabetical ranges possibly, although that's the least common range of values situation you would ever be faced with. But all of these three common filtering situations can be combined into a single select-based stored procedure, right? Now this one we've done, so I'm going to skip through these slides fairly quickly. We've done this to death already, where we have a foreign key lookup value, especially easy if it's one of these integer identity primary key situations, right? Where the primary key of the lookup table is a simple integer, right? So we can just have a where clause where we're checking that the field matches the parameter or some flag. Really easy if the values are integers. Our flag of 0 works perfectly in this case, and that's what we've done over and over again because of how our examples are set up following that standard approach, right? So that's just an example there. Sorry, I kind of skipped that one a little too quick. Showing you here's just a quick example then. We have university instructor is basically an advisor to many students. A student will have one faculty advisor. The common foreign key value here that makes it work is advisor ID is really just an instructor ID assigned to a student, right? So it's a one-to-many relationship with advisor ID as the foreign key. So a stored procedure, we might select, okay, whatever we want, all fields perhaps from university student, where the advisor ID, okay, matches our parameter that we pass in at the top, or equals 0, which returns all students regardless, right? Because if either side of an or is true, the whole expression is true. That's how Boolean or logic works, okay? And so that makes it very easy, and we've done that numerous times already. It doesn't hurt to have it in here reviewing the different styles of filters we can do. Now text strings, okay, maybe just before we get into the rest, other than situations like that where you have like an integer value, usually parameters work best in general sense if they're just string values. I mean, remember, a string can represent virtually anything. Okay, it can represent a number, it can represent dates, and so on and so forth, right? You can even use strings to represent an image, okay, if you encode it a certain way and things like that. So strings are usually what we're going to use for our data type for our parameters going forward. Later on in our code, we'll actually cast it to the appropriate data type we might need to use in the actual where clause. But usually the parameter itself will just be a string. So for text, okay, we'll have a parameter, usually a varchar, okay? Avoid char, right? Because the padding of characters that happens automatically with a char, a fixed length, right? So a varchar parameter of whatever size, just pick the biggest size you're going to need. Usually that's indicated by the fields you're looking at and so on and so forth. And then inside the where clause, it's easy. We have our two choices. You can do the contains approach using our like operator. You remember the like operator from TSQL? Like does a character comparison that is like a given pattern. And then we use our wildcards. The percent symbol in TSQL represents any number of unknown characters, right? So if to find out if it's contained somewhere inside the field, we just put one of those wildcards at the beginning and at the end of the actual character string that we're looking for to see if it's contained in the field. And that's perfectly good to find it anywhere inside the field in any of the records, and just the records that match will be returned. Okay, now a starts with is even easier. You just don't have the wildcard character at the front. So whatever characters you've passed in the parameter value have to be at the beginning, followed by anything else, right? And that's basically it. If you really wanted an exact match, obviously you could figure out the where clause to use there. You don't need me to tell you what that would be at this point, I'm sure. So that's pretty straightforward, text strings, right? Now, later on we'll see that we can get around this decision structure here of deciding, well, do we want a contains or a starts with? And if we just use the pattern of the starts with, then all we have to do is in the parameter stick on the extra percent sign at the very beginning, right? And that converts a starts with into a contains search, okay? But we'll see we can actually do that inside the user interface code, that right in the application itself. All right, ranges of values, this is the most work, okay? Especially following that advice I gave you a minute ago. Yeah, you know, you can in some circumstances actually have parameters of date time types and things like that. But honestly, years of experience in industry has taught me string parameters are the best to work with, right? Even if it's more work to convert them later on. So if you're going to have a range of values, that means you usually have a start and end for the range, right? So set up a couple of varchars to take those values. And we'll see that we can actually set it up easily so that you don't actually have to have a start value. Okay, you have to have one or the other, right? You could have everything after the start value, and you don't care about the end, and vice versa, okay, quite easily with this arrangement. But we start off with the two parameters for the starting and ending of the range, right? And then what we do is if an empty string is passed in, right, so there was nothing entered in the user interface, then we substitute the actual minimum and maximum values the data type would allow, right? So if I say I just want everybody who is born before a given date, right, and I put that in as the end date of the range, I can leave the start blank. And what we'll do is we'll substitute the earliest date the system can understand. So you can see we'll always then satisfy the requirement you can't use between. You probably remember this. In TSQL, you can't use between without actually having the two values to specify, right? Yeah, sure, we could, again, have multiple different stored procedures, one that has like a greater than and one that has a less than or equal to and things like that. But between is nice and flexible, and we get around that restriction and make it more flexible by doing this approach. So we just substitute the oldest date or the minimum value that's valid for the data type and the highest value valid for the data type if no value is actually supplied. That lets us use the same stored procedure code in both situations where we actually have a beginning and ending value for the range or when we just have one or the other. And finally though, okay, those are still strings at this point, right? So we do need, before we actually execute the select statement in the procedure itself, we have to convert them to the proper data type. So you can use cast or convert, right, to do that, because the between actually has to have the proper data types to compare to the field itself. So that's the last step. So we'll have a look at what that looks like in code, right? So our range of values, then, so you'll declare an actual start date and end date, for example, if we're doing dates, as a date data type, and then we just cast our strings, okay, that we've set where we substituted the minimum and maximum values allowed depending on what was passed in the parameter. And we cast them as the actual start and end date, and then we can just use this one where clause, but it will work for all three situations where we have a start and end value, or just one or the other. Okay, so it's a few more steps, but it makes it universally, it works in every situation, right? So good approach to follow. I highly recommend. All right. Okay, so that's good for the stored procedures. We can see how we can do a range. Obviously, if you're doing not a date range, but a numeric range, you follow the same logic, just you'll be casting as whatever the decimal or integer or whatever the data type is that you're going to be working with. And again, find out what the maximum and minimum values for that data type are and use that to substitute. If you're not sure, then just look it up in the help system, right? Okay. But often we need to take extra steps inside of our user interface, inside the web form, to work with that style of stored procedure. For one thing, a flag value for our foreign key lookup, so we can basically remove filtering by the foreign key. We add our all option. As I said, 0 works perfectly if it's an integer, but it might not be, right? So you might actually have to decide in certain circumstances to use a particular type of value different from that. Whatever you have to do at the time, just work it out and test it and make sure you've got something that works. Sometimes you can even use a string, just have a string parameter that you later on convert, right, to a different type. But having a string parameter allows you to pass in no filter or whatever flag you want, right? And in your logic, you just compare to that. If it's that, then you're always going to be happy and you return every record. Okay, now the other thing is the text strings, right? Because we're using string parameters for most everything else, we have to be a little bit careful, because by default, what a web form will do is if we don't enter a value, when it prepares the information for the parameter, it substitutes. Whenever it sees an empty string, it substitutes an actual null, right? But we've set up our strings, they don't allow null for the string parameter. It's going to take an empty string, not a null, right? So what we have to do is there's a option in the control parameter itself called convert empty string to null. It's Boolean, true or false. So we just have to make the extra step to set it to false, and then that way it won't try and substitute and will pass the empty string, satisfying the logic we're using in our parameter test to see if something was passed. That's the one extra little twist, and it comes up a lot because we use a lot of string-based parameters. Okay, all right, so that's basically it. Just a couple little extra things we could do. Another technique to get at the parameters being passed, this is something new we haven't seen before. We've played around for error handling, for database error handling, okay, with the after events. For example, like our inserted and updated events, right? We can examine and see the information passed back, error messages and so on from the database. But you notice that there also were the before events, right? The inserting and updating events, okay, of a data source control. Sorry, I know I'm saying that kind of funny. I'm trying to emphasize the tense, right? Well, inside there, it's before we actually pass the command off to the database, and we can go in and we can meddle with it, right? We can go in and we can examine all the parameter values that we want to and modify them if required. So, here is where we could provide a value that's not coming from the user interface itself. Perhaps you have one of those audit fields, for example, right? And we want to provide a value for the last updated by string value, right? Using something built into the system. We'll see later on, next term, you'll play around with the security system called the identity security system built into .NET, right? And inside, once you have somebody who's logged in, you can access their identity just with user.identity, right? And there's various parameters there. .name returns the username. So it's not going to come from the user interface, right? It's stored in the system to know that this particular user is logged in. So we can grab that information and provide it to a parameter for stored procedure that's going to look for last updated by, for example, right? So that's just a general example. It's useful in all different situations, right? Just I'll emphasize that notice that the @ symbol is there, the name of the parameter, right? It includes the @ symbol itself as a string. So we're naming the element in the collection of parameters by its actual full name. But in a similar way, right, we could do a starts with to a contains filter as shown in the next one. So maybe we have a checkbox on our form somewhere, right, or it could be a radio button or whatever, where the user is going to say, well, no, I want to, instead of a contains, I want to switch it to starts by or starts with or vice versa, right? So depending on that logical test, if some checkbox is checked, for example, then we can take the existing parameter value, right, and modify it, or we can just take the text right out of the text box and concatenate on that wildcard character at the beginning, right? So our stored procedure could be set up for a starts with, and by adding that extra character, we can change it to a contains type of a search. Okay. Just a note there about sometimes we have to refresh the data from the data source. Okay, if we don't see a change in a parameter. If you're doing it in code, the system might not notice it and we have to manually do it. But we'll talk about that in our example. All right, so that's just a discussion of the PowerPoint itself. I just want to explain some of the things. You know, the PowerPoint, I give those to you as a kind of a textbook reference, but sometimes they take a little bit of explaining. I think that one definitely does. So we'll have a look at some code now.